So we've talked today about microservices, and I want to try to sort of close this, the day by talking a little bit about some of the complementary things you need to worry about when you start working with microservices. And some of our speakers have already begun to touch on this. So when you talk about the hot topics in the industry at this point, and I get a chance to go to quite a few conferences these days, microservices is still there. I mean, there was dedicated tracks in conferences I was in several countries now. Microservices this year. The first dedicated conference of microservices I know was in Berlin in February. So it's going to be a hot topic. But there's sort of complementary technologies that sort of go with this. That microservices without some of the complementary technologies doesn't really make a lot of sense. But there's also, I'm seeing complementary sort of, I would say, business logic and business ways to run your business, from anywhere from lean startups to Agile and Programmer Anarchy and other managerless processes. You also see terms like, new terms like DevOps and full stack developers becoming more in vogue. And I see an underlying theme to all these things, and it's just basically because we're going to a point where we're trying to drive to go faster. That the business is trying to go faster, and these are the things that are helping it happen. And so as I sort of peel back the onion and sort of look at these things, the question is, why do you want to go faster? What's really driving this? And I see two things that drive this. First of all, to some degree, we're solving different problems than when I started writing code in 1968. And a nice way to sort of describe this is the Cynefin framework from a guy named Dave Snowden. Not the same Snowden you've been hearing about, but a different one. And he basically said the world can be divided up into several different types of problems. Simple problems are those where the cause and effect relationship is very straightforward. This is the world of the best practice. And in this sort of world, it makes a lot of sense to have a manager and a bunch of grunts, and you tell the grunts what to do because there's a best practice. There's something to teach them. So organizationally, that makes it a great way to solve these sort of problems. He also said they're complicated problems. This is where the cause and effect relationships are more convoluted. It takes a little more effort to understand what it looks like. And so this is the domain of the expert. So the expert understands how all this stuff works. Think about some of your financial domains. So the cause and effect relationship is there. And so because experts are really expensive, you typically need to hire some grunts to do the work. So you put a manager in place to make sure the grunts do what the architect tells them to do. So basically your traditional architectural structure of organizations, like some of the Indian outsourcing firms, are set up to do this very well. And this is the world not a best practice, but they call them good practice, because there's more than one way to do things. But Dave Snowden didn't stop there. He said there are other types of problems he's observed as well. So, oh great, clicker. Always get close. So he called one complex and one chaotic. Complex is where the cause and effect relationship is not discernible. Yes, if something happens, you can figure out why it happened, but it's not a predictor of the future. This is a world where experts are useless because there is no concept of an expert. These sort of problems are typically markets. Financial markets, Google AdWords, things like trying to find whether you're a good risk or not. These fuzzy sort of questions are in this complex domain. And just because I figured out a way to do that works 4 or 5 times in a row, I try the 6th time, it's going to fail. And you have to have no memory of that, go back and try something else. So you don't organize yourselves here necessarily with the experts and the sort of the grunts and the manager, because first of all, there are no experts. And if they claim they're experts, they're lying. But what happens is you can't tell the grunts what to do either. The manager is basically doesn't have a significant role here either. So what you need to have is a bunch of bright guys that sort of understand the problem you're trying to solve and understand some of the KPIs, and they attack it. And again, they attack it day after day after day, knowing that sometimes it works and sometimes it doesn't. And of course, chaotic is even worse because we don't even know what cause and effects are. So depending upon what type of problem you're trying to solve is a different organizational structure, a different way to attack these things. Now, one of the things Dave Snowden would say is basically there is a concept of disorder, which is the fact that most of the times you don't know what type of problem it is until you watch it, watch how it behaves, and sort of drag it to the corresponding quadrant that makes sense. And there's a caution out there, because you tend to have a tendency yourselves to like one of these segments. And you almost have a tendency to take every problem and try to define it into your own little segment. And that's very dangerous, because it may not be true. So you're a politician, everything is simple, If you elect me, I'll fix it. If you raise taxes, it'll go away. If you lower taxes, it'll go away. Whatever you're claiming. Of course, the problem is not one of these. Also, if you're sitting here with the experts, they just aren't kind of useless when your problem gets over that domain. Yet, you're an expert. You go out and tell your clients, oh, yes, I can solve this because I'm an expert in this field. Look at my resume. I'm an expert. I've done this for many, many years. When, in fact, it may be a completely complex product. A lot of the domains I've been playing with in the last 10 years or so have been in the complex domain. And a lot of the things that have come out of that relative to microservices and some of the management of processes are basically to address that segment. So another reason why we're into this space is the competition is coming. This was alluded to several times today about how disruptive the competition is when it comes. And this is because of two reasons in my mind. First of all, a lot of entry barriers have now fallen away. It used to be, in order to have a startup, you'd have to get yourself a lot of hardware. You'd have to spend $1 million on hardware. You'd have to go to Oracle and buy yourself long-term licenses. You'd have to go rent massive bandwidth from AT&T just to get yourself started, along with a large development team and another couple of years to get it done. Those barriers have fallen. A startup can basically grab computing when they need it, when they can sell their services, they can get the computing as they need it, they have lots of bandwidth, they get these massive free frameworks from very, very reputable companies that do these things for free. And so the technology inhibitors to competition are now gone. But even worse than that is also the opportunities and how to attack these opportunities. There are new ways to attack your customers. In particular, Silicon Valley is now the role model for how to attack a business. They aren't going to pick up Oracle. They're not going to be picking up older languages and older frameworks. They're going to be using the newer technology stack that some of the guys in Silicon Valley are using. There's a roadmap for them. There's no reason somebody sitting in India can't go attack your customers. They can bring up an Amazon instance in the local domain here. They can go siphon off your best customers because they can find them because of various micro-marketing capabilities that the industry now allows. The social networks allow you to find the key customers. And you can wake up one day and just, why is my revenue per customer dropping? It's because somebody has siphoned off all my best customers and I didn't even realize it. So if you're not innovating at the pace of your competitors will be taking your markets away. So this is why the speed becomes even more important. So the question is, how fast can you really go? I mean, what's really allowing you to go how fast? So, being an old guy here with lots of gray hair, I can go back and draw my history here. So going back to 1980, I can talk about how long did it take to deliver products from the time we had the idea till we get it out the door. And I'll start with 1980 in this case, and realize this is a log chart, so a straight line is really good, because that means it's really a hockey stick. So, in 1980, I was working at IBM. I was typically doing waterfall processes. In fact, in the 70s, I was one of the guys that experimented on when they invented waterfall. And I basically got an award about this time frame for a product I started 5 years before. So 5 years after it started, I got an award for safe, successful delivery. We didn't have any false starts. It just took that long to get it out the door. And I worked on a project almost the same time frame. We took 3 years, 1,000 programmers. We successfully delivered that. We also made $1 billion with that product. So don't feel too sorry for us. We did pretty well with that. But over time, and I was still at IBM, the second bullet here, we got a little faster. I started delivering about every 6 months because I was delivering a little less functionality. And even when I left IBM and started doing some of the object-oriented programming and started using languages like Smalltalk, I was still talking about 6 months, 4 or 5, 6 months, or sometimes even longer delivery times with our cycle. So not a lot of massive impressive gains, just kind of a nice hockey stick stuff. Even when Agile came along and we adopted Agile, and I started doing Agile, I think my first project was 1998 doing Agile. It didn't really get accelerated that much. We're still talking about delivery of 3-month releases in a very aggressive fashion. And then the bottom dropped out by something I'll call A squared here, which kind of says for aggressive Agile or Agile, or sometimes this is where my Programmer Anarchy, my managerless process. And all of a sudden, we're just kind of off the bottom of the chart. This is a hockey stick on a hockey stick chart. This is how fast you can really get going. And in fact, I worked for a company, and they published their own GitHub stats about how fast it could go. And 53 developers, which is a pretty good sized shop, they basically did 652 deployments in 1 week. That's about once every 3.5 minutes. This is from about 2010. So you can go really, if you think you're going fast now, you can go a lot faster. So what's stopping you from doing this? And this is where I want to talk about the things, other things that are sort of slowing you down from doing this. And the first set is sort of the technology things that slow you down. There is a thing called Valley Tech to some degree. I've had a chance to meet some CEOs and CIOs over the past few years. And it's sort of like, you always look to Silicon Valley and say, why can't we do things like these other companies? What's inhibiting us from doing that? And a lot of it has to do because you're not using a lot of the technology you're using. That for some reason you define these things away. Oh, we don't want to work on the cloud. I absolutely agree with the ADP point that said if you're not moving to cloud, that's the first thing you want to try to get in the cloud. But specialized databases, we can't use that. Or we can't use this new languages. We can't do the other things. So basically, these are the things they're doing. And if you don't sort of agree to adopt these things, you're not going to have that same sort of success that they're having. And by the way, again, your competitors are doing this, your niche competitors. So use the Valley Tech is very important. The other thing, another little chart, hardware lead times. How long does it take to get a piece of hardware to run on? Well, back in the day, it usually takes 3 to 6 months to order a piece of hardware back in the day. And this is 1990 now. And because by the way, that's kind of a lie because generally it's about a 15-month cycle because you have to request the hardware in your capital equipment budget, a year before. And so you have to sort of guess how much capacity you need 15 months in advance. And it's very scarce capacity. You have to make sure you use it exactly right. And so it had that sort of delay in there. And then we decided we could virtualize this stuff. And with virtual machine concepts, carving up this hardware into virtual machines and sort of allocating that instead, it was quite a change to how fast we could get things. You could get things in a couple of weeks sometimes to plan these things. But even last year, I was working with a client, and we said we needed a virtual machine inside your enterprise. And it took them 1 month to get us that virtual machine. 1 month. And they broke processes to do it. These guys are ripe for attack. But it didn't stop there because the really interesting thing happened. It was the Amazons and the various other commercial clouds became available. And now all of a sudden, within an hour or so, maybe 30 minutes, you could get yourself a virtual machine. And you didn't necessarily have to go through all these guys having to do other stuff. And that was pretty revolutionary. And then, of course, again, when you think you're really there, you get Docker coming out. And I run Docker on my notebook here. It's a Windows machine. I'm sorry, it's a Windows machine. But it runs Docker, and that means I can bring up almost anything in just seconds. So what's the impact of doing this? Well, one thing is you think about it and says, well, in that world over there, you needed a lot. It's a scarce resource. You had to have lots of control over. You had to understand. You had to plan around it. In this world, all that stuff goes out the window. All those are useless exercises. So basically, if you're worrying about capacity planning as part of your business process now, you should forget about that. That's a complete waste of time. Move away from it. And a dedicated ops team, yeah, when you have scarce resource, you need a dedicated ops team. When you're working with something like this, no, not necessary. If you don't realize these changes, and these are institutionalized things within large companies. These processes are well established. Where's your capital equipment plan? How much machine do you need? I got entire staffs that are running around trying to do that with companies. And not to mention the very large ops teams. And to some degree, when you adopt this stuff, it goes away. And this is what kind of microservices have done, is they've sort of said, oh, look at this world. I don't have to play in that world anymore. I can play in this land. And so along comes basically the microservices. Again, I draw a little graph to sort of represent where I think the microservices. And by the way, this is a log chart. So it's log in both dimensions. And I kind of have what I call the Rails and Java zone, which is like this one app, lots and lots and lots of lines of code. I did play with SOA in some of the days of SOA, and it kind of felt like this. In fact, I think if Credit Suisse was one of the guys at the time playing in this space, and they were kind of like this spot on the chart. Quite a few services, 50, 60 services, but they were quite large. They were 30, 40, 50K each. But I think this is where the microservices kind of lives. Much, much, much smaller. And we can get away with having lots and lots and lots of these because we have an easy way to get places to run them in. It's easy to get my virtual machines. It's easy to get the containers. And that was not so much the case in these era. And that's one of the big shifts as well. It's how easy it is to actually get containers to run these things in. So, I worked at a project in India about a little over a decade ago here. I will never do that again. Not the India part. The India part was very fun, but working with a gigantic code base, never want to do that again. I have a workshop I run, and this is where we sit on the chart. We're running about 15 or 20 services, and they're kind of running about 30 lines or 40 lines code each. This is the company I work with in London that a lot of this stuff comes out of. We have lots of experiences that we talk about that. They had over 300 services, nothing over 100 lines of code. Netflix, it's the best of my knowledge, this is where Netflix stands. If I'm wrong about this spot, help me move it, but this is where Netflix stands. So we're all in that same space of running in these large virtual machines. So one of the things I would ask you if you think you're doing microservices is where do you fit on this chart? Where's your ratio of various other things? But these are guys that now, because of the phenomenon on the previous chart, this world is now open to me, and it provides a lot of opportunities. Another major technology shift, and this comes largely again from Silicon Valley, is the emergence of the Eventbus. The Eventbus is beginning to replace the operational SQL database. So we know from historic designs we have an operational SQL database, and then we have sort of the reporting database. And we have two of these because we know the patterns of querying and the organization and optimizations are radically different. The operational database is dying. I would say in most of the cases it's been dead for a long time. And it's being replaced by these companies by an event bus, which is basically just a place where everything going on is running through the event bus. And that, you can certainly pull things off and put it in your data warehouse, build your CRUD transactions off of these things. Very easy to do. A good example of this is a Kafka bus. Kafka is the bus that's used by LinkedIn. So it's been in use, I think, over a decade at this point. It's now been made an open source project. It's part of the Apache project. The documentation on the Apache site is amazing. Great justification about how it works and how to bring it up. There's even a Docker instance you can bring up that brings you up a Kafka on its own. But it's a persistent bus. And it's a really, really dumb bus, which is one of the advantages of it. It's a really dumb bus. It's one of these buses you don't spend a lot of time configuring every time you add a new service. It's not doing transforms for you or all the other stuff some of the enterprise services bus did back in the SOA days. Those were bad ideas. And an enterprise service bus is just as fragile to your organization, just as much of a monolith as a big SQL database. The Kafka bus is relatively dumb, but it actually has a really high capacity. It'll handle 250,000 messages a second, which in most of my environments I tend to work in is more than enough to handle everything interesting going on. So not only do we put basically our messages to various services, every one of our log messages, which is an event, gets put on the bus. User journeys put on the bus. Traffic stats for our various servers on the bus, which gives us this wonderful stream of information and messages that says, this is what's going on in my enterprise. If I want to debug something going on, it's already correlated for me. Now, it turns out these guys cheat when they measure these things. When they say 250,000, they mean 250,000 messages. But if I write one and read it 10 times, that counts for 11. So if you hang 100 services on this thing, all of a sudden it's not great capacity. So typically what you do then is you hang off something else off these things that sort of pulls off sets of messages and hands them off to the service themselves. In one of my designs, I call this the rapids, and this is the river because it has less messages content. So you kind of minimize this, and I haven't had a design yet where I needed more than 10 rivers in order to handle this. So that keeps my capacity at still 25,000 messages a second. And if you're a service, you kind of you hook yourself into a river, but you always publish back to the big bus. That allows everybody to see anything interesting going on. And this is a technique, by the way, we also stole from Google. Because Google had the concept, if you do something interesting with a piece of code, publish it. Don't worry about who's listening for it. Don't worry about who needs this. Publish it anyway. So if I come to a page and I'm doing a search, publish that event. If I show you a spelling correction, publish that event. If I use a spelling correction, certainly publish that event. If I ignore the spelling correction, publish that event. Now, they didn't know what they were using this for, but it turned out to be useful in the future. And they didn't have to go into all these other services and make all these changes with all the other departments. It was already there. And so we take that philosophy to heart as well. Now, this yields some interesting new architectural patterns, particularly for solving those complex problems, those reference problems. This is one I call the need pattern. The idea is you have a service, you have one of these message buses, and you say, I have a need. I have a need. Can you help me out here? Now, you have to worry about, in these cases, these asynchronous cases, that you may not get an answer. That's perfectly a valid thing, or maybe not get an answer in time. You've got to worry about that case and handle that case. But hopefully there's other services out there listening for this need, and they will offer you solutions. And you get solutions you'll be listening for, you pick up the solutions, pick the one you like the best, and you use it. Nice asynchronous algorithm. It's not your typical algorithm for running these things, but works extremely well for those complex problems, like credit risk and the like. The nice thing about this structure, it allows you to write variations. I can write a new version of the blue service, keep it running in parallel to the old version. Instant A/B testing. The blue service doesn't have to tell the first blue service it even exists. Doesn't have to tell the yellow service that exists. Doesn't have to tell the green service that exists. I can just deploy it. No other dependencies. And if the green service goes down, by the way, of course, the blue service is still answering. I'm still getting answers, maybe not as good, but it's graceful degradation. So for these fuzzy problems that live in a complex domain, this sort of structure is very, very powerful and very, very fast to deploy. Example of this, because of this sort of thing, you can sort of now create these what I call incremental applications. I think one of my ThoughtWorks colleagues, former ThoughtWorks colleagues, calls this never done. So in this case, let's have a rental car site here. I have a couple places I can put some advertising here to sell you more services because you came to my site. Let's sell you some additional services for the rental car agency. So I got my legacy system like that I haven't been working with. So I go put myself an Eventbus in place, write myself a little surrogate here that says, once this page comes up, put a message on the bus that says I get a chance to put some offers up here. I got a service that's running on behalf of the overall brand for the company. It's saying here's some corporate programs. An individual specific location may have a surplus of cars. He can actually bid his own services as well. They don't know about each other. And I can bring this up and have it running a few days. But I can keep adding to it. I can add another service here that keeps track of your membership in my frequent renter program. Because I know if you're you're already renting from us and we don't rent all the time, I have special offers for you. I want to keep you as a customer. I may have done some segmentation on them to find out your rental patterns. Knowing that if you rent during the weekday, the chances are you're not paying for your own car. It's being paid for you by your company. So therefore, I should probably not give you a discount offer because you don't care about discounts. You care about points. And again, I can keep adding these services, and keep adding these services, my system gets smarter and smarter as I go. Very powerful sort of architecture possible with microservices and using event buses. So you have this concept of event bus coming in. But you also have, and this has been addressed a couple of times today, the database. Is that kind of the holy grail? I mean, having that consistent operational store has been the holy grail for how long? We still have never gotten close to proving that? Or is it really a ball and chain and holding you back? And I would definitely say, you've heard today already, it's a ball and chain. It's a monolith that holds you back. So if you look at the Fortune 100 view, they want to build these entity-oriented databases, these perfectly consistent operational stores, and they try to get there. So, true story, I was working with a client in this region, and basically I was talking to their chief architect. And I go to the chief architect, being a bit of a troublemaker I am, and basically said, well, how many operational databases do you have? And he kind of sheepishly says, we have 3, we're trying to get it down to 2. I said, that's really interesting because the right answer is 300. It was the last conversation we ever had. It was okay. He was going off apparently after this meeting to talk to his vendor about the new waterfall process. It's like, I don't want to talk to him either. But when you move to the event bus, which becomes sort of your central information store, then you basically have a little bit of database on a per microservice basis. I think somebody's already talked about this in our panel this morning. Yeah, basically every microservice has persistent store if it needs it. And you can tune that store to whatever it needs to do. Key value stores turn out to be very useful for a lot of guys because most of the databases, it turns out, are read-only. You're only pulling information out of this store to help make a decision. In my experience so far, and it's not a lot of experience, but about 10% of the stores are writable, but only about 10% of that 10% are actually transactional. And think about that a minute. That means just because one service over here has to have a transactional database doesn't mean all the rest of us are stuck with Oracle or SQL Server. We can use the database we need for our needs, and it makes us faster. So some examples of that just from the little rental car example. If you open up this rental car service, it's actually going to be lots of little pieces of code I'm going to write running in individual containers. I'm going to have a little thing that's sitting there watching the web page. When the web comes up, it's going to publish a message on the bus. That's the end of that little service. That's all it has to do. This little guy is going to wait for all the solutions to come back in. Different piece of code. Yes, you could put these together, but it sounds like it's going to publish an event and listen for the answers. I use the and word. No reason to not separate them. Now, when these answers come back in, you might as well just stick them somewhere to hold on to them, because you probably have to wait, especially if you're supporting IE6, you're going to wait 300 milliseconds to have to give an answer. So let's just put them in the Redis database, and when that guy wakes up after 300 milliseconds, he reads the Redis database and gets it out. That's running in its own little container. This is running its own little container. There are 4 containers here. I would still call this one microservice because it has a shared piece of data, but I'm writing 4 little pieces of code here. Another example, if you open up membership, very similar story. I'm sitting here on the bus. If something comes in about somebody I know about, I'll actually republish the message and say, oh, by the way, Sally is also a platinum member to our rental program. I'm pulling this information out of a key value store that I actually populate every night from the data warehouse using some little ETL process. Now, you can say, well, what if Sally does something right now that makes her platinum? Don't I give her platinum immediately? The answer is no. I'm not going to bother. Don't think I need what's the business need for that? Tomorrow should be platinum, next offer she gets. Is that good enough? How much money do I lose by having that 4-hour window between now and then? Or what if this ETL process doesn't run tonight? So I'm working with yesterday's data. I can live with that. That's not too bad. If that's a really bad problem, I'll fix that problem. But I can start off very easily doing these things, and very easy. And again, it's unlikely that your existing ETL processes actually publish key value stores. So I'll write a little service that runs your queries from your data warehouse, turns it into a key value store, and puts it in that little database. So again, little databases scattered out throughout the system that do exactly what you need and no more. I don't have everything about Sally here. I just have that Sally's user ID, and I map it to her status in the membership program. That's all I have there. So the database gets scattered to the 4 winds. And again, the Eventbus allows me to do that because everything is still there, and I'm still keeping my data warehouse up to date. So open source, God bless Netflix. Thank you guys wherever you are, Netflix. Massive, massive implementation of amazing microservices, open sourced, I think 40 or so open source frameworks. If somebody told me I had to build a real commercial strength application today, this is where I'd use. This is where I'd start. I'd start with their stack. There's certainly a lot of major clients that are doing that already. I think including the US Department of Defense is doing projects using this Netflix stack. But you also have other key open source contributions. And I can't overemphasize how much Docker has impacted the industry right now in terms of this, in particular, how fast container structures are in general. And there are some competing containers out there, certainly. But from almost nowhere to where they are now has been a pretty amazing story. At the Microservices conference in Berlin, every speaker stood up and talked about microservices, also threw Docker in there as well. So if you're trying to think about these outside of each other, you should also be thinking about containers as well with your strategy. And finally, disruptive languages. There are some languages out there that if you're not interested in not getting into, you're missing a key opportunity. So functional programming languages are coming. It is kind of the hot topic. You've heard about it. They're not largely adopted yet, but in fact, they've been very, very powerful in many places. If you look at some of the middleware, like Kafka's written in Scala, RabbitMQ are very common things written in Erlang. These are not your typical Java and C# languages. These are very strange languages. Case study. So I worked for the Mail Online for a while. Yes, we do publish things about Kim Kardashian. It's very important to keep track of what she's wearing every day. But the legacy system, and by the way, the Mail Online is actually, the Mail Online paper is actually the largest online newspaper in the world. I think 1 month, like 2 years ago when I was still there, we published 3.2 petabytes of data in 1 month. And that does not include video. So we're talking about a massive, massive rendering of pages. The rendering system for just rendering the pages themselves across the newspaper was 130,000 lines of Java code and JSPs. 2 CTOs were brought in to try to make this easier to change, so we can have some changing capability there, and failed and were fired. Third guy comes in. We basically wind up putting some new technology in place. We rewrote the system in 4,000 lines of closure. So there's certain problems that, things like functional languages are silver bullets. And if you're sort of forbidding your programmers to play with these things, you're maybe leaving a lot of money on your table that your competitors will not do. So yeah, massive, massive difference. And by the way, this system is very easy to change, and they're having a field day and all the additional things they've been able to do now. Again, certain type of problem, this turns out to be a silver bullet. All right, so that's the technology. We got event buses coming, we have languages, and we have the cloud and exploiting the cloud. And that sort of corresponds with using good microservice strategies as well. But what about some other inhibitors? There are actually a lot of process inhibitors within your organization as well. So the first one you got to do is, first thing I would ask a client is, look at this chart. What problem are you really trying to solve? Because until you know what problem statement you're working in, you may be organized incorrectly. Yes, if you're doing an accounting system where the rules are in place and the experts exist, you're doing this sort of thing, maybe there's no pressure to do microservices at this point. But if you're in this domain here where you're trying to figure out whether somebody's a good credit risk, or whether somebody will have a tendency to leave the organization, is a flight risk to your organization, is happy with being in your organization, there's fuzzy sort of questions, you're in the complex world. And if you're organized this way, you will not solve those problems very effectively. So figure out what type of problem you're trying to solve. If you're in that fuzzy world, we have a new vision of how to think about this thing. Because this is a world where the experts don't exist. We sometimes tell the story about what's the difference between a used car salesman and a customer. And the answer is a used car salesman knows he's lying. So if it gets to be a complex problem, I don't necessarily trust what even customers say they want, or what they think they need, or stuff like that, because frankly, they don't know. What we can do is measure some things around that. So it used to be when you're working in one of the other segments, you can have requirements. We can put those into stone. And I got to, first of all, apologize, because this is, the fact we have requirements processed the way we do now is, frankly, a little bit of my fault. It's my generation's fault. Because when systems got a little bigger, I started telling the customers, stay away from us, tell us what you want, we'll build it for you, because it's going to take a while. And so we taught them to stay away from us. The fact that they want to stay away from us now and don't want to re-engage is, my fault, because that's what we asked them to do. We have a new vision of what we want to do. We don't want to do, requirements are certainly in the complex world, mysterious. We don't know what the real answer is. We need to move to the world where we're trying ideas out. Tell me about an idea you have. Let's see if we can try it out. How fast can we try this idea out and make it work? And this is the domain of the complex stuff. This is the complex domain. This is the way you want to start thinking about things. Don't take requirements from these guys. Say, come, help us understand what you're trying to accomplish. We're going to try ideas out. In one company, we came up with this saying from the programmer side: experimentation drives innovation. If you really are into innovation at all, this is a key word. You have to try things, and you should expect failure. Experimentation has with it the concept you will fail. Get used to it. Sometimes my role in many of the companies I'm working with is to be the guy when something fails, and some guy says, well, if we had some more meetings about this thing, we wouldn't have these failures. My job is to tell him to shut up. And if you don't want to listen to me, we'll find the next executive up the line, and he'll tell him to shut up. Because we're not going to go slow just because we might make a mistake. We're going to keep going fast, fail fast. So experimentation driving innovation. We also want to rethink how we're interacting with our customers. Almost a decade ago, a colleague of mine in ThoughtWorks, we drew this pyramid, and basically sort of talks about the various levels of how requirements work in Agile. So most Agile processes talk about stories. We break stories into tasks. We also observe that stories are part of something bigger, we might call a feature, which is kind of something bigger called a project, which can all be tied to some general business initiative. And the one thing about Agile is the traceability we have. In fact, if you got if you're ever saddled by SOX compliance, the traceability in Agile is absolutely gorgeous. It just nails it. So most of the time, most of the Agile process said, this is where you want to interact. You're interacting with the people at the story level. This is your customer interaction level. However, I've done Agile consulting now for over a decade. I walk into a lot of shops, and this is what I see. You look at the stand-up, listen to the stand-ups, look at what they're talking about. Everything's about the task. What task you work on, how long it take you to do the task, what task you're going to work on today, why did it take you so long? And the programmer has no idea what's going on, and he's completely demotivated. So one of the things we did, especially solving complex problems, is we changed the focus of the interaction. We now go to the customer and says, tell me what you're trying to accomplish. Teach us a little bit about your domain. And they go away. Let me do my job. Now, because I'm delivering so fast, you're going to see stuff like a fire hose. It's going to come back in just a massive stream. So yes, even though you don't know you're lying, we'll see we're trying ideas out. This means, by the way, your job as a customer is to help teach me the domain. Let me understand what problem you're trying to solve. And we work accordingly. So, change the level of interaction. Very important for success here. Finally, we need to measure what really matters. I can tell you as a programmer, I've been measured by lots and lots of things over the years. Lines of code, function points, compile units, you name it, we've had it. And frankly, as a programmer, it's whatever game you want to give me, I'll play. Whatever game, and I can win these games. We can always win these games. So it turned out when we started giving the new metric, it says, let's put business metrics. Let's measure how much money we made yesterday. It turned out the programmers get really excited about this as well. It's like, how many sales do we make? How many clicks do we get? What's our page retention times? And I write some code and deploy it and see if I can get that number bigger. And I can tell you how many times the customer was amazed that we tried something they never even thought of because it raised the metrics. They said, what'd you do? Oh, we tried this. That worked? Yeah, it worked. Look at the metrics there. Wow. Teaches the domain. Now, sometimes they say, well, my domain's really complicated. You can't understand my domain. It's really complicated. It's like, okay, dude, let's swap jobs. You pick up Clojure. You try to deploy on AMS. I'll take your domain for a while. Let's see who's got a more complicated world. We can understand their problem. This is not the issue. And so most of the organizations, we've eliminated the whole concept of business analysts in between me and the customer. I want to talk to the guy. Several of our speakers have talked about that. I want to talk to the people who have that. I want to understand the business problem I'm trying to solve. All right. So that's kind of some of the process stuff that needs to change. We need to raise our level of interaction with the customer, get rid of a lot of the intermediaries. Finally, we have some organization inhibitors as well. And the biggest one I run across in organizations is we have tended to over-specialize. Somehow the theory is a specialist is faster than a non-specialist. Yes, that's kind of true in theory, and that's always been kind of the theory behind it. But in practice, the overhead of the communication is never considered. This is the whole just-in-time movement, right? The whole just-in-time thing was realizing that specialists are not faster when you look at the overall process. This is where the idea of full-stack developers, DevOps, and these things come out of this. So because of the imbalanced workload creates those delays. The problem is, of course, the specialties have been institutionalized. Most often been institutionalized by titles and job descriptions. This is what you are. You're a back-end Java developer. This is your job. Your career path is to be a better back-end, a senior Java back-end developer. It turns out these are not the guys we want to have. So this, again, is a case study from the actions we did at the Daily Mail. Again, 2 CTOs fired before we got there. We had 50 IT professionals in the organization between operations, QA, and development. We had 25 plus titles. And we had 0 people knowing what we're doing. Literally. Nobody had the big picture. It was not part of their job. So this is what you started out with. And so basically the idea was, okay, we got to do some radical surgery here. So the first thing is we fix the titles. Because they were fixated on the titles and the promotion paths. So we had to create a new system for doing that. So first of all, we sort of defined what we thought were competencies. So I'm kind of a big fan of the master journeyman apprentice model. Sometimes they have different labels. Sometimes they're 4 or 5 levels. It doesn't really matter which one you use. In my world, this means you're competent in this technology. In other words, you can use this technology all day and not screw it up. Apprentice can't do that. It needs to be handheld. And a master, well, they're kind of masters. It's kind of hard to describe what they are. But you can use these technologies in very strange ways to do very crazy things. And then we identified what we consider to be the key technologies in the company. In our company, we said Java because we're already a Java shop. I tried to kill that one. Couldn't kill it, but I tried to kill that one. We used Ruby. We were basically on mobile platforms, so we were iOS and Android. We had back-end and front-end. JavaScript was important. Object-oriented design. I tried to kill testing because it's kind of integrated. Couldn't kill that one either. And database, both SQL and non-SQL databases, to be understanding. So we had our strategic list. And so then we basically said to the team, we have these new titles. The new title is going to be basically you're called a developer if you're competent in one of our key technologies. You're useful. You're a developer. You're a graduate developer. You're not. I'm not sure why I hired you if you can't do JavaScript or you can't do Java, but whatever. But you're a graduate developer in that case. And you're a senior developer if you're now a master. And this, of course, is a traditional path. So we kept that concept. But then we played some more games here. We defined ourselves as something called a system developer who was basically competent in 5 to 7 of the key technologies. This is a full-stack developer. I call them poly-skilled programmers. But this is the sort of guy that I give a problem to, a business problem at a feature level, and he can help carve it up between database part, here's how you run on the cloud, here's what your front end needs to do. He can sort of carve it up competently and attack the problem, which is what I want. And so these are very, very valuable people. And we said we will pay you the same as an expert. Same pay scale. You don't have to become an expert, you can become poly-skilled. And we treasure these guys. And we defined something called a master, which was up there just to have a target, but 3 to 5, master in 3 to 5 technologies. And we basically said you have a dual career path. You can go either way you want to. So I went to Human Resources of the Daily Mail. Now, the Daily Mail was founded in 1895? 1890, actually, in 1890. So it's 125 years old. It's run by Lord Rothermere, the 4th Lord Rothermere of his title. So think old, staid English company. I'm going to the Human Resources, says, I have a new way of finding people. What do you think your reaction is going to be? Yeah, the laugh there. They loved it. Surprised the hell out of me. They loved it. They've been trying to get out of the business of taking these sheets of descriptions and trying to plot them programs for years. I just said, I'm going to handle this for you. And they were like, take it, dude, take it. They were perfectly okay with this. So we basically told the programmers, because again, in the UK, we are under EU regulations. We just can't change people's job descriptions willy-nilly. We said, if you want to work on the new stuff that we have coming, this is the new title structure. If you don't, that's fine. We got legacy code. It's going to be around there for the next 5 or 10 years. There's plenty of work for you. You make the choice. Most of them chose to come to new titles. Notice there's no title here saying manager. No title here saying team lead. Because those are situational topics. Those are situational roles. So the other thing is dedicated leadership. I don't believe in dedicated leadership. It's a, quote, a full-time manager role. Partly because of the sociology book like this, which basically said, if you read the stuff about that, is in primitive societies, you never had a dedicated leader until the village got to be at least 100 people. Otherwise, the leader was the guy working in the field with everybody else. You want to know who the village leader is? He's out there working. And that's kind of the model we want. We want to have the leadership sort of emerge from the group, but otherwise you're writing code like everybody else is. You're understanding requirements. The other mistake we tend to make is because projects have been so long running, we tended to create projects as we needed them and pull the team together and have them put together. So we put a new team together using our spreadsheets. Well, it turns out that's really a bad idea when projects get faster and faster because teams have a gelling time. It's much better to sort of have the team in place and bring the new expert to the project. So rather than play musical chairs all the time when I have a new project formation, keep the team together. They work well together. They've got the roles defined. They know who's good at various things. They're working well together. Bring the domain expert in there. Explain the new domain to them. Let them start implementing it. When he runs out of money or runs out of ideas, bring another domain expert to the same team. Keep the teams together. So that kind of wraps it up. So the idea here is to try to convey a little bit that if you take microservices by itself and says, I'm going to do microservices, and you're not considering some of these other things, you will fail. Or at worst, you won't get any of the benefits you're talking about. So you probably need to think about at least a little bit of picking some corresponding technology. You definitely want to be in the cloud, pick a container technology, adopt some non-SQL database technologies, rethink your titles, and you're probably going to move to some sort of process that has fewer managers, or certainly managers that are not doing the traditional management role. Because again, for the type of problems you're trying to solve, managers are not helpful. So that's a story about going faster. All this stuff, microservices, in my mind, is just one of the techniques of going faster, but if you're not doing the rest of the stuff, you will never get the benefits you're trying to accrue with this stuff. I thank you, and I think we're going to bring up Sadi for his closing remarks. Thank you.